With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is, if inertial mass is mi of a bomb of a simple pendulum of length is L is not equal to the gravitational mass mg, then time period is, now we have to find the time period. So in this question it is given that this inertial mass is not equal to gravitational mass. Inertial mass is the mi and the gravitational mass is the mg given. Clear? Now let us consider a pendulum of length is what L. So this is the pendulum we can consider, and length of the pendulum is given, that is L. And displacement of this pendulum, let us consider this is the mass and this. So this angle is what? Theta. In this direction, this is the theta. So gravitational force mg will act in this direction due to gravitational mass. So this is what? Mg into g we can say in this direction. Now mg sine theta will act in this direction. Mg into g sine theta will act in this direction. So we can find the torque. As we know, torque due to this mg sine theta about this axis, torque is equal to this force mg and g sine theta. Mg is what? Gravitational mass into L. Now we can see that this due to this torque, it will try to rotate in this direction, and theta is in this direction. So we can take minus here. Clear? This torque is equal to this. Now for a small value of sine theta, for a small value of theta, we also know for a small theta, we can write sine theta is almost equal to theta. So we can write this torque is equal to minus mg. For this small value, we can write sine theta is equal to what? Theta. Clear? So from here we can see that this is equal to mg into g theta into L. We can write this torque. Clear? Now let us consider this is the first equation. Now torque is also equal to I into alpha. This is the moment of inertia into alpha, and the I is what? M into, we can write L square. So mi we have to take inertial mass, we have to take mi into L square into alpha. Clear? Let us consider this torque, and this is what? Second equation. Now from first and second, clear, we can write this mi L square into alpha is equal to, we can write this mi means inertial mass, L square, and alpha is equal to, we can write minus this mg, the gravitational mass, into g into theta into L. Clear? Now from here we can see that this from 1L, this L is the cancel out. So we can find the alpha from here. So alpha is equal to, we can see from here, alpha is equal to minus mg, gravitational mass, into g and divided by into theta and divided by, we can write mi, and this is what? Mi. Clear? Now if we compare this equation, alpha is equal to minus omega square and theta. So omega square we will get from here. From this equation we will get omega square. So omega square is equal to, we can see from here, mg g and divided by m into I, we can write. Clear? So from here we can find the omega. So omega is equal to mg g and divided by mi, we can write. Now into L is also here, mi into L is also here, we can write mi into L. Clear? So we can write L here, mi into L we can write. Clear? Now we have to find the time period. As we know, time period is equal to 2 pi and divided by omega. So from here we will get the time period, and this is equal to, time period is equal to, after putting this omega value. So omega is equal to what? Root under this we can find. So here also we have to put the root under this. Clear? So this time period is equal to 2 pi and divided by omega, and omega is this, we can put here. So this is equal to root under mg into g and divided by mi into L. So after solving, we will get the time period, and this is equal to 2 pi and root under mi, inertial mass, into L, and divided by, this is what, mg into g. Clear? In this way we can write. So this is the required answer for this question. Now according to option, we can say that this B is the right option for this question. Hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.